So myself, I am Rajesh. I am working as a project engineer, and profile wise I am the faculty in CDAC Advanced Training School. So today's topic is Android Open Accessory Protocol. So some of you have heard about it. Then we can see the different perspective of whatever the protocol is, and those who are new will see what the protocol all about. All the things, we'll just do that one, just 2 minutes. By seeing the title or the few small abstract available on the site, so what you could have understand, I think I can go by your expectation, because the topic is slightly vast. It is not a purely embedded Android kind of topic. It involves Android as well as certain kind of hardware, but since most of you are not so familiar like hardware like me also, so what you can do is, we can take any simple Linux machine, whatever laptop, PC or any embedded board which is running with the Linux, we will use as one end, and another side will use as the Android device, and the communication between these two nodes, that is, one is the Android device and then the hardware running with the Linux OS. So the communication is established by the Android Open Accessory Protocol. So before going to that, if you can just share some expectations, accordingly we can drive the talk. Instead of purely going on hardware or embedded, you may not be interested, or maybe slightly different, or you want to focus more on Android side. So can I get some inputs? What is the expectations here? So first, anyhow, 15 minutes, no choice, we have to see the basics and flow of the protocol. Without that, then after that 15 minutes are, if you divide into 3 parts, the second part and third part, so how we can drive it, we can see. So one is the Linux end, the machine running with the Linux, and one is the familiar Android, that is a theme of the track also, and then the flow between them we can see. Fine. So I think I can slightly briefly discuss about the flow on the Linux side, and then how the communication happens on the Android, and if at all you want to start with the app development for accessory development, we can go ahead. So before going ahead, now we need to talk about what is the need for this protocol. The protocol is called as Android Open Accessory Protocol, and whatever the additional device we are going to attach to the Android phone, we will be calling it as ADK host, that is Accessory Development Kit. So most of you know, there are certain kind of sensors in every phone. What are the typical sensors? Some accelerometer, gyroscope, magnetometer. So what if you want to add some more peripherals to your Android phone? Like our phone don't have the temperature sensor, or it may not have the PWM support, it may not have the CAN bus support, or simple serial connection also not there. You want to have any serial kind of communication, RS-232 communication. Suppose I don't have a NFC reader in my, NFC support is not there in my mobile. Suppose I want to add an external NFC hardware, so that may be attached through our serial interface. So if you want to add this kind of interface, what are the choices you may think of? There are some other choices, not only Android Open Accessory Protocol, there are different choices are there, how you can add more peripherals to the Android phone. A sensor which is not available if you want to add it. So you can add one more sensor. Whenever you add a sensor within the Android device itself, as you know, the kernel cannot support whatever Android kernel given by the vendor, by whatever the shipped by regular vendor. So what is required is, we need to do certain kind of changes in the kernel in the regular way. That requires, as you know, rooting. So without rooting the device, how to add more peripherals? So without disturbing the existing kernel, that means without rooting the device, how to purely within the app only, how to communicate with the various additional peripherals, that also you can call it as accessories. Whatever additional hardware you are attaching to our Android phone, we can call them as the accessories, peripherals, or external sensors, external hardware, one and the same. So the second requirement here is we don't want to root our device, we want to add more peripherals. So is there any other way before going to AO protocol without rooting and without adding doing any changes to the kernel? Any other way to add more peripherals? Yeah, Bluetooth or Wi-Fi you can do. Mobile, the one side you can have the Bluetooth or Wi-Fi. The external hardware you can expect Bluetooth adapter you can attach or Wi-Fi. And as you know, Bluetooth and Wi-Fi has some power consumption issues, performance issues, especially Bluetooth, the slowdown and the pairing issues and all. And Wi-Fi also, if you see, certain the other hardware should have the Wi-Fi adapter, and again you need to pair it or make a connection by using Wi-Fi. But what if you can achieve with the USB? If you compare USB, Bluetooth and Wi-Fi, so what is your choice? USB, because of performance and because of the sophisticated and the no packet drop and all the issues, so we can happily connect an external hardware using USB. But when you come to USB again, I think some of you may aware, if you go into internals of USB, there are two choices. Now the Android device can work in the USB host mode and it can connect in the device mode. So most of our devices will it's not having USB host port. I think most of you are aware of it. The typical high-end phones may have the USB host port, but any low-end phones, if you take any $200, less than $200 or whatever it is, they are lagging the host port. So most of the simple devices will have they work in the device mode only. But each and every phone will have USB device port, all of you can agree. I think no Android device gadget nowadays without USB device port. OTG port will be there, that OTG port will be working in the device mode. So that is typically supporting your file transfer or the ADB protocol to support that one, so device mode will be there. So and moreover, even though the high-end mobile has the host port, so there are certain kind of cons. If you are going to use the host mode of the mobile, that is obvious, that is draining the battery. If the Android is running in the host mode, it will drain more the battery. So we don't want to compromise in any issue, we want to add external peripheral through USB only, we don't want to drain the battery. So for all these things, one solution is the protocol. The protocol is called as Android Open Accessory Protocol or ADK host, or you can get accessory mode. So here the idea is the Android gadget will be kept in the device mode only. So no need to worry about host port or battery draining. And whatever additional hardware you want to attach, could be microcontroller, could be any other device, we can choose in the host mode. So that the advantage is the gadget battery won't be drained, it will be in the self-powered or whatever bus powered mode. So the external hardware will be supplying the power, and still we can have the communication between device and the mode. So here we want to highlight some terminology here. The Android, now onwards you can call it as Android gadget, Android device doesn't mode, otherwise you can say Android app, whoever is on one side. On another side you can say whatever external hardware you are attaching, that can be called as accessory development kit, Android accessory development kit more popularly. In short it is called as ADK, or it is also called as accessory host. So once you choose any external hardware which is having USB host, and our device will be connected with a USB cable, simple OTG cable, so we can have the established using simple USB communication will be there with simple two bulk endpoints. I think I am not going to the internals of USB. If you have any queries, we can in middle or at the end we can have clarification. So those who are having typical queries on the USB side or whatever the driver you are going to develop. So the terminology and the need wise, you have any other issues here you want to share something. So before going ahead to the actual details of the protocol.
Does it allow both options or only?
Sorry?
Does it allow the Android device to be both host and device? Or
no, for host is entirely different APIs. Because in the new versions 3.1 onwards, I think entirely different set of classes are designed for host mode. So we can depend on those things.
this is for device
Though the total, most of the talk today's focus is on the device mode. So without compromising in the host or the battery consumption, so how to have a communication between the device mode of the Android and then external hardware. So when I say external hardware with the USB host, what are the choices we can think of? I want to add some sensors in the form of external hardware with some USB host port. So what are the various choices? Which devices will have the USB host?
Big devices like TV.
Yeah, TV, but the problem is TV don't have any our control. The program designed for TV is not by us, it's not under control. So we haven't flashed any code onto the TV. So you can think of some of your, of course, slightly different domain, that is an embedded domain if you go. Sorry? Arduino, like any kind of microcontrollers or microprocessors, embedded boards if you take up. So those will have the host port. So, but you may think that is not the theme of the track today. That is a mobile application development, and most of you may say we are not comfortable with the typical hardware programming or microcontroller programming or any other embedded hardware. So no need to worry about all the things. So what I have done is, so with the basis of some other, the Mr. Gary Bissons has developed some Linux ADK code in the user space. So based on that, a small skeleton driver was developed for Linux, but one small constraint is you have to choose Linux platform. If you are not using any other hardware, fine, you can use a regular our laptop, notebook, netbook or whatever it is, but the most of the code and the flow was designed in Linux. But after seeing the flow, if you are interested, you can design with any other platform. If you have Windows SDK or some other SDK Mac, if you have the same flow, you can be designed. So the choice is open. But as a proof of concept on the flow, and most of the boards are supported in the Linux, so I have chosen the Linux as a platform. So we are going to use the Linux as ADK now. And any Linux machine, if you see, most of the Linux machines will have the USB host port. The simple example for Linux machine is our regular notebooks, netbooks or desktop PCs, which will have the host port we can connect to the mobile. So before going to that, there are two versions of this protocol. The first version was released in 2011 for 3.1 onwards. I think that is Honeycomb, because I am not much into Android recently. I have started with the Android side, but I can give more on the flow between Android and other side. So, but still for the 2.3 Freud and all words, you can have an external library with an add-on library. But 3.1 onwards is, I think, almost way back, 3 years back. The mobiles are supporting this kind of protocol, but most of the thing is we are not aware and we may not have explored that kind of feature. And it was announced in Google I/O 2011, and they have chosen a custom shield for a plug-in hardware for the Arduino board, and it was demonstrated. And there were some changes, and the next year 2012, the second version of the protocol was released with the support from 4.1, that is Jelly Bean onwards, for API level 16 onwards. That was the widely used nowadays. We are not depending on AOO 1 version, we are using the AOO 2 version. And the second version of this protocol comes with additional features. Not only the simple hardware external communication, we can use ADK as audio dock. That means whatever Android audio is coming up, that we can route it through the ADK host. That means whatever Linux or microcontroller, whatever you are attaching, so that the voice, the audio, complete audio from the mobile, we can route it through as a dock. You can use external dock, and it has some HID support. I think again HIDs we can discuss later beyond the theme. And apart from the USB communication, those who have difficulties, they are also supporting Bluetooth connectivity. But today's talk we are going to focus more on the USB connectivity only, and it was announced in Google I/O 2012. So they made a custom kit made of again Arduino Duo board, and it was demonstrated in the AOO 2 version. So based on these Arduino shields or Arduino kits made from the Google, people come with different boards available in the today's market. Like Arduino has two versions, Mega and Duo, and then some embedded artist has some AOO specially designed kits for AOA protocol, and we have something called FTDI, I think most popularly hardware vendor. They have some VNC2 hardware is there. Microchip has one hardware, SparkFun. I think you heard of BeagleBone, that is from Texas Instrument. So without Linux also, they have their own small kind of no OS concept is there. So they have developed one small layer for this Android Open Accessory protocol. So this is all in one side, all whatever hardware mentioned, and the last one is another side, that is Linux. Because advantage is the moment you can think of the Linux, you no need to change your code again and again. Suppose I am developing for my notebook now, the same code or same development efforts I can easily migrate to the any other board running with the Linux, Beagle board, Raspberry Pi, BeagleBone. So I think most popularly nowadays, most of us familiar with the Raspberry Pi, which is running with the Linux. So all these boards are having with the USB host port. So we can choose this kind of any Linux machine we can choose. As a limitation of hardware connectivity, initially I think till 12:30 I will focus on my notebook only. And I think in the networking break, if you want to have a hardware demo of the session, so I have a BeagleBone available with me, so that is connected with the mobile. So how we can do the LED control on the BeagleBone we can do. So the advantage is Linux is widely supported many platforms. So anything developed on the Linux we can easily move from different platforms without changing. But the problem is other hardware is they have their own APIs, their own firmware sets, their own architecture issues. So the code developed for one kind, let's say if you develop for microchip, the same efforts cannot be used on FTDA, the same efforts cannot be used on Arduino, because everyone has their own ends. So that's why you can use Linux as a good platform. For that, then user space based code was available, but based on that, in the recent few months back, what I have done is I have taken the idea of the protocol and developed a kernel module. So if you are interested, what you can do is take the code, no need to worry about the driver design, just take the code, build it, you can just introduce into the Linux kernel. So once that module is introduced in the Linux kernel, now the Linux will have the ADK capabilities, and without knowing, no need to worry about USB functionality and any kind of the driver programming from the user space. I think most of you are familiar with simple file operations, open, read, write, close, or simple shell commands using sysfs. So using that you can easily control that. So before going to that, just a minute, how much time? 12:05, okay. Now if you want to use device in the AOA mode, there are 3-step initialization is required. The first step is every device will have the USB basic something called control endpoint will be there. You want to start any kind of USB communication from the host to device, you send some control request. So the first you have to say the Google has decided this kind of specifications, we can't change them unless you modify the Android open source project AOSP. So these codes are fixed by the and most of the mobiles what you are getting 4.1 onwards or whatever, these codes are fixed. So you have to send a control request of 51, that is hexadecimal 32, to just get the which protocol you are going to use. If the mobile is supporting 1.0, it will return 1. If the mobile is supporting 2.0, it will return 2, or error in case of it is still older phone prior to 2.3.4. If the device is not supporting a protocol, you may not get the response. So first you need to ensure, I think some clarity that going. So this is the dot, there is the dotted line here. This dotted line is a request and the second line is a response. So the ADK, that is Linux or whatever it is, will send a request. So on behalf of the request, our device will return the version number, that is the first step. And secondly, we want to send some strings, because we may use different accessories, Raspberry Pi, BeagleBone, Arduino, or something like SparkFun, FTDA, which accessory you are using, or especially for which purpose you are using. To recognize your additional hardware, external hardware to the Android mobile, you have to send some around 6 strings, that is manufacturer. You can write any manufacturer your wish. I can write OSIDS, Google, something like that, your company name. So you have to send one manufacturer name. Particular to your application and the hardware interaction, you can decide one model name. We can give one model name, let's say LED control, something like temperature sensor, like any one model name. Some description of your application and the interaction. Some version you can decide. If I keep on releasing more apps, more kind of firmwares, so each kind of release you can have one version. And one URL you can say. Suppose a suitable app is not installed on the Android side. Now what you can do is, the URL concerned to the getting the APK file or the more details of the application you can send, and certain serial ID you can send. So these 6 strings individually you need to send through control request 52. So again using the USB basics. Again if you use a driver skeleton, you no need to worry about all the things. I will show you simple commands. But for understanding internals, I am telling you all the things. But if you use the driver skeleton, whatever is designed, without understanding, worrying about all these internals, we can easily do that one. And then for each of the things you have to send the string ID. String ID you can use 0 to 5 as mentioned in the another second table. And what is the address of the string and length of the string. So as per the USB specifications, you need to send the 6 strings. And the final step is we have to send the control request 53. Now the moment you send the 53 request to the mobile, nowadays USB will have 2 modes. I think you are aware of what are the 2 modes? The USB connection will have, if you see, it has camera mode, that is PTP mode, and another one is MTP mode. So I think earlier mobiles and the recent from the beginning onwards they are supporting PTP mode, and recent editions they are supporting the MTP mode, and that again you can choose with or without debugging, right? So there are total 4 combinations will come. The USB mode of the Android, if you talk about, there will be total 4 combinations, that is with or without debugging, and in with or without debugging again 2 modes, that is the camera mode as well as media mode. But the moment you can initialize the device, it will deviate from camera and media mode, it will entirely go to a new mode called accessory mode. I can show you very soon, just a minute. Right now, sorry, it's missing now, I will show you. So the moment you initialize the device, now it is going to use in the accessory mode. That means now the mobile is ready to talk to the external hardware, and by that time it is expected hardware is also ready to whatever the data communication for your application side. So like this we can prepare our mobile first, or whatever gadget, not only mobile, sorry. So for this kind of external communication, and beyond the accessory mode, so we have also additional options like audio mode and HID mode. So I think we can discuss, if time permits, towards the end, what is audio, at least audio mode, how to do that one. If you are interested in audio mode, what you can do is, before sending this accessory mode, we can send another control request called 58. If you do the 58 mode, then the mobile will be, that device will be settled down in the audio as well as, that is accessory mode. So that means it will be supporting audio dock as well as it can talk to the external accessories. For that we can send this one. So have any kind of issues with the first 3 steps? Yes.
So this audio support, this control request will be sent by the mobile to the dock, or dock?
Initially the dock will send to the mobile. Now the mobile will give a permission or access to the external dock. So that time it will whatever the native speakers of our Android won't be disabled. I mean routing won't be there, and all the audio of the mobile will be routed to the ADK now. But everything you have to initiate from ADK only, because we have chosen the mobile in the device mode and ADK in the host mode. So mobile cannot initiate anything here. That's why all the story was happened. Otherwise it could have used simple APIs. You can ask, why can't you use simple classes and simple APIs? The reason is we have chosen the mobile in the device mode. It cannot initiate all the things. So everything initiation will be done by the ADK. As per the ADK request, the mobile will respond accordingly.
58 control request for audio will also go from the
ADK only. And if you are doing like that, the specification says please send it before sending 53. So 53 is the final step for accessory mode. So before sending 53, if you send 58, now the device will settle down in both the modes, accessory as well as audio mode. So that means mobile will be in audio support will be there as well as accessory support will be there.
the mobile will be working as an audio source.
Audio source, yes, and ADK will be acting as audio output. The Linux will be acting as ADK dock or whatever, micro Arduino or what.
Also act as mobile being audio sync, like playing the audio for some other microcontroller.
That was whatever mobile audio is coming, that will route through the microcontroller.
The other not.
Not other way. Yes. So that means ADK will detect our mobile as input source. It's like audio jack. It's like a recording device. Mobile will be acting as a recording device to the ADK now. So I think any issues with the initialization? I think towards the end of the flow of the protocol. Now once if you decide that, once you follow all the 3 steps, since you are using the devices from various vendors, Google, Samsung, Motorola, like many, LG like that, every device will have its own configuration. The vendor ID and PID for each and every device from the various vendors will differ, but in order to work with the protocols, we want to come with a unified configuration. So before initialization it can have any kind of configuration, but once it will settle down with a kind of initialization steps, it will provide one unified configuration. In the unified configuration, you have 6 options. That is purely accessory mode, we don't want any audio HAD support, and ADB is disabled on the mobile. Or suppose if ADB is enabled and then I am using the 53, then it will go to the second option. For all the things, vendor ID is Google vendor ID, that is 18D1, and the product ID will be 2D01 like this. And then audio only. If you skip the some of the strings like manufacturer and model strings, if you don't supply it in the second step, so still you can communicate between Android and ADK and your Android, but only for audio and HAD support, that is audio only. And same way audio with ADB combination. And if you do 53 and 58, both if you send accessory and audio, then the device will settle down in accessory and audio mode, and again everywhere ADB combination will come, with or without ADB. So like that total 6 combinations will come. So if you want to see, let's say how the device looks like, there is a simple command in Linux called lsusb. What and all USB devices attached to my machine you want to see, that is lsusb. Now can you spot out our mobile, that is, it has Motorola or whatever vendor ID and product ID 22B8 and 284. It keeps changing it. Suppose if I change the modes, like from camera to MTP mode, it may give another ID 2E76. It doesn't matter. Before initializing the accessory mode, we can have various kind of vendor ID and product initialization, but in order to use this one, you want to have a simple one unified configuration, so that application is aware of, confident of talking to the external hardware. So I think we can go with the initialization of the hardware now. For that I will use media mode, so that it won't collide with the ADB and other file transfer modes. Even MTP, if it is colliding with your some other file transfer and some other services, please disable them, unload the drivers, any storage drivers or any other services like volume managers colliding with this kind of USB functionality, we can disable in the beginning. So I will load the driver now. Without worrying about internal design of the driver, there is a simple command called ins mode. So you can take the driver from the GitHub site which is hosted, you can build it, simple steps. It's a one-time job, because for each and every app, each and every hardware, you don't need to change the driver. That is the advantage of this, using the driver because it has some layering advantage. So all kind of application or hardware specific code you will be doing in another layer, and common USB functionality is pushed into this driver. So first I am loading the driver. Once if you load the driver, are you aware of the sys directory? In the Linux there is something called sys kernel. A new directory was created called ADK Linux as per our request. In that one more directory was created called initialize my mobile for AOA purpose. Now it has 3 attributes are there. One is a version, to get the version, and second one is identity, and then the third one is start the mode, whichever mode it is, accessory mode or audio mode. So how do you get the version? Simply you want to get the protocol from mobile. It is a incoming request from device to host. So for that I am using cat command. So I will use sys kernel ADK Linux AOI init version, and it returns version number 2. So you no need to worry about any control endpoint now. You no need to worry about what is the USB basics, how to write a host side programming, because the driver will take care of all the things. As an application programmer, if you are purely into Android side, so you don't want to do much on the Linux side or USB side, you can simply invoke like this. So I think it is comfortable. So only thing you can do from any other language also, either shell command, or you are purely interested in the Java. Through Java you can fire the native commands or shell commands through whatever interface available to you. So you get the protocol. The next one is you want to issue the identity strings. Minimum essentially you can send 3 things: manufacturer, model, version. Version also optional, but for clarity. But essentially you have to send 2 strings, that is manufacturer and then model. So the application designed to talk with the hardware is expecting the manufacturer like OSI days, which is designed like that. So I will use 1 minute. Manufacturer equal to I will use one OSI days, which will be sending it to the another attribute, that is identity. So we can send this manufacturer string like name equal to value pair to the identity. Next I want to send the model. Model equal to, I think I have written it as LED sample, just give me one moment. It is LED sample, and the third one is version. I have chosen it as version 1. To identity. So 3 identity strings we have sent. If as patience level permits or the necessity goes, you can send all the 6 identity strings also, minimum 3 or 2. Then the final step is you want to send the start in audio mode as well as accessory mode. Audio is optional but accessory is must. So in order to start in the audio mode, simply I can write echo audio to start, and same way accessory. First 3 letters only significant in the driver, so you can skip. If the length in a manufacturer, you can write man equal to model MOD, because the driver recognize only first 3 letters are to in case insensitive. So now, now the device has turned into USB mode, but unfortunately I cannot mirror the screen right now, so I had to use one non-standard technique. Just a moment. Till now the screen sharing is disabled, because the moment I deviate from camera mode, the ADB is disabled now. ADB is not working in accessory mode. Yeah, can something is visible there? Okay. There is one small dialog box. I think, let me focus. Yeah, I think better now. There is a small dialog popped up now, that is LED OK, and it says open LED control with this USB accessory. So I think I can have the screenshot, I can show you. So it looks like, yeah, this was the screen what we are showing, this with more clarity. So the moment you initialize, a dialog pops up on the mobile side. So there is an external accessory specifying the strings like OSI days, LED sample with version 1, and there is a registered application in my mobile with these strings. So shall I allow the external hardware? Because without permissions, if you ask allow any other hardware externally, they may damage or they may do any kind of malicious things. So you want to have certain kind of authentication. The authentication will happen based on these identity strings. So here you can choose the option like yes or no. The moment I choose OK here, now my application will start. Whatever LED control you have designed will start. Now the application will look. So again I am coming to camera mode. So I will show you what is that application was designed. Yeah, I think once again you can see that application. So this was a small application designed for as a proof of concept to demonstrate hardware communication, which has 4 switch controls, 4 checkboxes, and there is a time text box. I think time will come here, and then there is a small slider bar. So if at all your hardware has 4 LEDs, now what we can do is by turning on these switches off and on, we can control the LEDs, or you want to control the trigger mode instead of doing on and off manually. If we can do trigger complete continuous triggering, so you can select here. By selecting here, the trigger is on. Of course right now I am doing an UI only, the status. Finally the data has to be sent to the through USB to the external hardware. So like that I can control the LEDs, and if at all the ADK is sending the time, the real time clock of the details of the ADK, the time will be updated here, and that SIG bar I am leaving it as open now. I am not implemented anything. So you can control the volume of ADK, brightness of ADK, so that you can do that. For time being, for dummy data will print whatever the brightness volume is changed like that, but really we are not doing anything. But if you connect some other hardware, we can control the LEDs. So the design of application, I think you can do better things than me, I think, because I recently started Android development. So but like this, if you do, our main focus is on how to communicate with the external hardware. So the launching of the application, you have any queries? You will get this kind of application. Or suppose if you cancel it, once again you reopen this LED control, then a dialog comes like this. Allow the LED control app to access this kind of USB accessory. Now that is on the Linux side. On the ADK side, how to manage this communication between the Linux side, how to initialize the device. And then once you do that one, so I think the steps are mentioned, you can refer them later. So you can load the driver, and then you can send the cat command and suitable echo commands to start the device. And of course, if you can ask later, if you don't want to do these commands every time, there is something called IOCTL and module parameters. They are too specific to Linux internals. So if you can offline, you can discuss those options. I think these options I have chosen because any other programmer, not only Linux programmer, any Java, .NET, any programmer, you can aware of this kind of, sorry, .NET anyhow, I think compatibility issues. So any Linux based language, if you take Python or anywhere, you can fire these commands, you can check these things. And once you do that one, what happens is, we will get one device here called AOSKEL. So for this you can write small initialization scripts also instead of writing everything. For example like this, for LED sample, this is a script, shell scripting. So I will trigger the script. Media device. So now application is ready. So once you trigger the script, then you will get one device file that is called I think ADB is still running. So you will get one device file like this, AOSKEL0. It is a simple device file like any other file. So this is the agent on the Linux. Finally, we will settle with the driver. So using this agent, what you can do is file operations for any language like C, or if you are more Android side means you may be comfortable with the Java, Python, any language. We can do the simple read-write operations on the Linux side. That is like this. Open the file in the read-write mode. You want to send something from the ADK. Then you can use the write system call or any other API as per your language. You want to read something from ADK, you can use the read. Once the communication is over, you can call the close. And you want to have asynchronous communication between ADK and the device, you can go for the threaded design. So that's most of the Linux. I think you have 5 to 10 minutes, I think less than around 5 to 10 minutes min only. So I think Linux side, you have any queries? Now you may be wondering, by sending these strings, how exactly LED sample was launched? So for that you can have a quick tour of how the application was designed, and think that is the more focus also. So I think today or tomorrow I will again host whatever the new things on GitHub. So it is available on GitHub site, the driver and some documentation reference. So you can please note down this GitHub, the driver, documentation. Some more things may be updated in another few days. Yeah. Yeah, but there you can get from USB, there is A2DP protocol is there, and using simple Bluetooth communication using L2 cap or RF com. So the ADK should have Bluetooth adapter, and your Linux machine or any other Android will have anyhow Bluetooth. So but APIs will change, not the USB APIs, they will be using the Bluetooth APIs. But most of the audio support, HAD support is available in the version 2. So because version 1 purely started with the accessory mode and version 2 was introduced with the new things. Now for first thing you want to focus is the manifest file. That is a key important thing. We are going to use a new package for this USB communication, so you can have users feature android.hardware.usb accessory. So I think already if you are any features you are using, you will be adding this kind of feature request. And mainly here this is the content you need to add to your manifest file. I think we can't go exact place, I can explore the code later, I will show you in a better place. I think zooming issue. So you have to write an intent filter for your application. Now the intent filter says whenever hardware USB action is USB accessory attached, whenever attaching any accessory, so USB manager will detect one event, that event is action is called as accessory attached. So now the USB manager will identify the manufacturer strings or the manufacturer model and version and try to map or compatibility between app and hardware. Same thing, when you are attaching, what are the compatibility issues and how the verification should happen, that will be described in an XML file that is called as accessory filter.xml. So the XML file is like this. So this is a magic between how that the mapping happens between accessory hardware and then the application. So this is the, I think visible, the XML file. So XML file should be written like this. USB, this is an USB accessory, manufacturer equal to OSI days, model equal to LED sample, version equal to 1.0. So these are the two changes to be done on your first thing is on the Android side. So that now the USB manager will try to match the right accessory and give the access to the right application. So once that is done, again for the flexibility issue you may be wondering, I am not aware of USB APIs on Linux side or Android side also, how to start? To avoid all these issues, again we have made a small experiment, that is all the USB related code was pushed into one class called ADK control. Initial days, few days, without worrying about all the USB management on the Android side, what is USB manager, what is something like getting accessory, how to send the data, how to receive the data. So what you can do is, you can just copy, but I can't call it as a library, it's not that much sophisticated. Right now I can call it as skeleton code, it's a template. So please add a class called ADK control to your workspace or project. So once ADK project is added, now the step is like this in your activity constructor or on create. In the activity on create, you can create one instance simply, one like this ADK control, ADK equal to new ADK control. Or what is done is, for some kind of getting the reference from multiple places, a singleton pattern also introduced. We can call ADK control dot get instance. Please pass the main activity, whatever the main activity is there, so that ADK control can update back or whatever you take the control, we can do this. That is of course, assume you are doing in the main activity, I can. So here you can do in the on create, can you see here, ADK equal to ADK, that is the total UI control or whatever the rendering and all, we have pushed into another side, that is called your activities. You can have multiple activities, tabbed activity, fragments. So irrespective of dealing with all the things in USB mixing it, so all the USB management is done by the ADK control. So you can create one ADK, get the instance from the singleton pattern. Can I zoom it, any idea? Okay. Now if you want to send any data from your application to the ADK side, now the ADK control can have one kind of command called send command. Suppose in a listener, I am triggering it. So I will prepare one buffer data now, buffer 0 I will maintain it as LED ID, LED type, I am controlling LED. So buffer 0 will be filled with 41, buffer 1, that is the first one buffer, second byte of the buffer will be filled with the LED ID, is it 1, 2, 3, 4, and the third byte will be filled with the buffer state. whether the LED is on or off. Once the buffer is prepared, again what you need to do is ADK dot send command. So in some other listener, again checkbox trigger for triggering also, the buffer 0 is 42 and then buffer 1 is whatever the LED ID and buffer 2 is the trigger state, it is enabled or disabled, true or false. Again you are sending the buffer. Same thing, sig bar change listener, we are sending the sig bar status by using code like 43 as first byte, second byte will be representing the state of the sig bar. This is a very simple thing. From any UI control listeners you can call the send command, that is from app to ADK you are sending some data. But the other part is slightly trickiest, that is how to get the data from ADK to the Android side. So application do like this, first we will send a 5 byte data, the first byte is a peripheral type like 41, 42, 43, you can decide any values, so that your Linux also should recognize the same bytes. Second one is the peripheral ID, third one is third onwards you can send the peripheral data, what is the data of the peripheral. Same way while getting, we can get, first one is the type of the input code, your temperature sensor or some other sensor data. So first one will tell what type of input you are sending, second byte onwards you can send the data from the hardware to or whatever ADK to mobile. So for reading again what is done is, there is a simple method is called read data in the ADK control by dealing with all the streams and all. So by there is a read data method is defined in here in the ADK control class. So in the main activity you can create one more thread. I think as you know better because of design practices, we cannot have a while continuous loop in the activity, that may block or kind of issues. So to update your activity based on your external data, you can create one thread, run method of the thread. In that what you can do is adk.read data, and once the read data comes, you can update your UI, whatever time if you are sending the 4 byte, first byte is the time code, second, third, fourth are hours, minutes, seconds. So I can send that data and then go ahead with the whatever the updation is there, we can do like this. So I think we are running out of time. These are some sample apps available. Before designing, you want to have some people like me. Initially I am not aware of Android programming, so what is my choice is, I had to get some applications from Google Play Store or get some source. So you have to get these ones, communication from ADK side, developing your own apps. And sorry, one most important thing, the ADK control class has designed with some methods called resume accessory, pause accessory, close accessory like this. So advantage is, whenever your activity is getting pause, resume, close or destroy, you can call this methods, pause accessory, resume accessory and then close accessory you can invoke from the suitable places. If you do any kind of suspension and resumption, how to restore the instance and how to save the instance, that will be taken care of in these methods. So and on the Android side like this, you can create one instance and you can use the read data method and send command methods to communicate between your apps. Or optionally you want to do raw communication, you will get the input output reference streams, file streams. You can obtain the get input stream, get output stream of the ADK control class. If you take, using that you can have the raw communication as per your choice. So that is within the time, because very some different wide versatile topic is there, but just customizing, trimming the topic, and then we will be able to manage this one. And how the ADK control was designed, I will share the code in few days, today or tomorrow, so you can have a go ahead with that. So what are the various service manager, how you are initiating, and these are few steps, how you are getting file stream, and finally magic is, after all initialization on Android side, you will get two streams, one is input stream and other one is output stream. If you follow these steps and you get the input stream and output stream, rest all the application follows how you are going to use the input stream and output stream. Like in your listeners, you can use output stream and write, and in your thread you can use the input stream and update your UI back. So like that you can develop or design your own applications. So thank you. I think within that, sorry for small delay.